For those of you that don't know me, my name is Crystal. I'd like to welcome you all to the webinar this morning. Thank you for joining us. Today we have Madi presenting the Siklu webinar. If you have any questions, go ahead and input them in the question box, and I will read them back to Madi at the conclusion of the webinar. And at this time, I'm going to let Madi take over. I hope everybody enjoys the presentation.
Good morning, everyone. Again, thank you for the introduction. We will have half an hour together, and obviously I'm open to any questions, guys, that you have. So let's start. I'm with Siklu, and basically I will go through our product offering, some prices information, some technical information. And again, please feel free to post your questions here, and I'll try to address as much as possible. So we at Siklu, basically, as you can see, we're shipping since 2011, and there are more than 7,000 links already deployed around the world. Couple of thousand here in the US and around the world. Basically, we are operating in all those areas where E-band is regulated, and because this band basically requires regulation. We were the first ones to came with this breakthrough solution for last miles, and we were the first one to integrate all this technology into ASICs, as I'll show you in the next slide. Basically, this was a breakthrough because still then, this technology was basically done by district components, which required for the least two units, one indoor, one outdoor. And when we came up with this idea, we brought to the table a unique solution, which is a small factor, low cost, and fully outdoor. Fully outdoor means that you don't need to care about co-location, you don't need to care about shelter. Basically, you just hang your radio over the air, fully outdoor, without any protection, just power and data, and you're good to go. And basically, you can have your service within hours. So this is where we, and this is what we bring to the table. So as you see, this is our basic building blocks of the radio, and you see our name, Siklu, here on the major component, and this is our basic know-how. The antenna feeders, all the antenna design is our design. The RF chip, which is silicon germanium, our design. It's a very sensitive technology, but we were able to integrate it into a silicon. Same goes to the CMOS baseband modem. The only part which we basically buy off the shelf is this network processor, and we're enjoying both worlds. We're enjoying our technology, which is a unique technology, and we're enjoying off-the-shelf network processor, which brings in all the Ethernet standards, features, etc. So this is a very highly integrated design, which basically brings a very high MTBF. Our calculated MTBF is more than 70 years, and with our field experience by now running from 2011, actually we are more than 80 years proven MTBF. So let's introduce this technology, which actually a band 70 and 80 gigahertz spectrum, 10 gigabit spectrum. So we're talking here about products on the 70 and 80 gigahertz. Basically, here in the US, it's regulated, lightly licensed. As you can see, link registration is approximately $75 for 10 years. Really affordable. It's very good that it's licensed, because basically you have your FCC in your support in case you have interference after you have been registered your link and there's interference from neighbors. FCC protects you. The process is fairly simple. There's a big database of the FCC and you just register it in. The FCC confirm that there is no potential interference in the area and basically give you a confirmation. So this is fairly easy. In Canada, it's still not regulated, but it's in process. We're involved in this process, and hopefully by the end of this year, it will be regulated as well. Hopefully sooner. And you don't need to work directly with the FCC. We can provide you these registration services as well. So we have totally big spectrum, lots of bandwidth. Our channels are 500 meg, and we can bring up to 1 gigabit, as we will see in coming slides. The links are basically approximately 1 mile, so 1.5 mile. So the spectrum can be easily reused, very low interference. Just from perspective from the beam, it's very narrow beam, so the channels can be reused easily by adjacent links. One of the things which affect the distance, and that is why we are not going to higher links, higher than 2 miles, is because of absorbance of rain. Rain has this effect on the link budget, and basically it reduces the gain, the budget, and we have some way to work it out to have better availability even on rain, but still rain is one of the effects that affect the link and limit us for reasonable availability, as we will show you a couple of examples. Limited availability, so for limited distance, high availability. So the product family, our 1200 basically consists of TDD and FDD product. TDD product are operating on the lower band, on the 70 band gigahertz, and the FDD products are operating at the 70 and 80 gigahertz product. We are talking about point-to-point solution, which means point-to-point with clear line of sight. Very important to have clear line of sight, which doesn't really, affect the link budget. Speaking of the TDD product, we are ranging from basically from 700 aggregated all the way to full gigi, and the FDD basically runs up to full gigabit, full duplex capacity. The TDD product, which is nice about it because if you see later we'll see the prices, is a nice cost-effective solution for those applications where you don't need really the full duplex symmetrical throughput. Let's say applications such as CCTV, where you have clear flow of traffic one direction to another, and either direction is basically some sort of a control. So with the TDD product, you can configure different asymmetry in your throughput. As you can see here in the numbers, from 50-50, which is the default configuration, all the way to 90-10. So 90% of the throughput, let's say 900 meg, will go to one direction, and the rest, 100 meg, will go to other direction. So it's really helpful for you to have a cost-effective solution for those types of applications that do not require really full full symmetrical throughput. Obviously, symmetrical throughput is also available, as I said, in default. And with the FDD product, we're talking here about full GIGI, full duplex. Each and every product comes with 9 channels, as we said, 500 meg bandwidth. We run up to 64 QAM. The 64 QAM modulation basically bring you the full GIGI capacity. And another feature that we have built in is the hitless, errorless bandwidth modulation coding, which basically this feature mitigates rain absorption. So in case there is a rain, in case we see that the link budget is dropping down because of rain absorption, we start this built-in feature, which you can obviously disable, but it's enabled by default, and we start to, without an error, hitless and errorless, reduce the modulation from QAM64 to QAM16 to QPSK, while still maintaining the link. We're reducing this modulation because when we reduce the modulation, the lower modulation brings maybe less capacity, but actually brings more link budget. And by addition of this link budget, the addition can be something like 20-25 dB to the link budget of the radio. It basically compensates on the link reduction because of this rain absorption. So this is a built-in feature, very useful feature in order to have still high availability on rainy days. It's fairly easy to install. We're talking here about the 1-foot integrated antenna, which is 77 Libra, and just hanging on your belt, and the installation is fairly fast. The tool is required for do the alignment, just a digital voltmeter and open range of 1/2 inch, and basically that's it. No need for sophisticated laptop or any algorithms to align and commission the link. Low power consumption, power by PoE or DC. PoE, which standard 802.3 AT plus. The PoE basically enable you one cable installation, both power and data on the same cable, and basically it's enough for having the link functional. Obviously, as I said, DC power is also available in case you want to use either a standard telco battery or additional power supply, 24 volts. Advanced layer 2 features are built in. Features such as QEQ, such as QoS, such as OIM, such as SyncE and 1588 included. Obviously, it depends on the hardware, but in general, those features included. Even AES encryption, in case you have a sensitive customer who likes to have his on-the-air radio secure transmission, either 128 or 256, AES is available on those radios. All in all, it's affordable. Later we'll show you the prices. Scalable. Operational expenses is minimal. As I said, very low power. No need for any right-of-way. No need for local location. No need for shelters. No need for any, let's say, cooling or heating elements for that. So really fast and affordable deployment. Two words about the difference between TDD and FDD. As you see here, we have on the spectrum of E-band, and we discussed that 70 and 80 gigahertz. The 80 gigahertz I regard it as the higher band, and the 70 is the lower band. And the TDD products basically operate only on lower band. We mentioned that, while they operate in master-slave operation, which means when one side transmits, the other side receives, and basically the master control the bandwidth to each side, and this is how basically we can control asymmetrical throughput allocation from all the way from 50/50 all the way to 1090. And FDD, on the other hand, works on both band, the high and low, and one side transmits on the higher, the other side transmits on the lower side, and basically this one brings you the full capacity, full duplex of 1 gig. One of the things to remember here, when you're building a TDD link, basically all you need is to take 2 radios of your warehouse and rush it to your site. If you're building an FDD links, basically you need to make sure that one side would be transmitting in TX high and one side transmitting in TX low. So eventually you will have a link. If you will bring only 2 radios from same kind, obviously there won't be any link. So this is something to pay attention, and this is very common in the industry, but just to remember. So a few words about the interfaces. There are 2 or 4 interfaces, depends on the hardware. The 4-port module, which is the FDD product, basically come with 2 versions, either 2 copper and 2 fiber, or 1 copper. Obviously the copper is reserved for the PoE in case somebody wants to use a PoE. So 1 copper and 3 SFPs, 3 fibers, and you can choose your way of technology, LX, SX, ZX, whatever is available for you. We support all. Basically, the reason for fiber interfaces is because the copper interfaces are limited with Cat5e cable length, which is 100 meters only, and in case you need to more cable, you want to more distance, you want to use fiber for that, and this is the reason why we have more interfaces with fiber in such applications. The product that has only 2 interfaces, this is the TDD product. Basically those interfaces are combo interfaces, meaning that there are 2 Ethernet dedicated ports, but you can choose either copper or fiber per interfaces. Default is copper, but you can easily configure it to fiber and have your fiber connection to the TDD product. While looking into those interfaces, this is the power connector for the radio, and this auxiliary port basically for the digital voltmeter probes to be inserted inside, and when you insert your digital voltmeter inside, basically you push this product to alignment and you can read the reading, the received signal reading on your digital voltmeter and know exactly what you need to fix in order to have a good alignment and have your link ready for successful deployment. So there is no need for laptop or anything sophisticated like that. We have 2 types of antennas, basically 30 and 60 centimeters, or 1 foot or 2 feet antennas. The 1 foot antenna is integrated antenna to the radio. 2 feet antenna are actually external. So when you buy a 2 feet antenna, it means that you need to order a radio separately from the antenna. So it's like a combination of two items, as opposite to the 1 foot, which comes already integrated with the antenna. As you see, the gain here is 43 and 50 dB. And as you see, the beam width is very narrow, less than 1 degree. That's why it is important to have a good alignment because the beam is very narrow. The other thing is important here is to have a solid, firm pole. We recommend a pole between 2 to 4 inches thick or 4.5 inches thick for the 2-feet antenna in order to have obviously the pole stable and not vibrate, because any vibration, any sway of the pole because of wind load, the alignment can move a little bit. The beam moves because of that. As you see, it's a narrow beam, so you may lose part of your alignment, part of your budget, and we don't want to do that. So that's why we have a recommendation, certain minimal requirement for the pole thickness. And after obviously you're doing that, you're good to go. We have a very good experience here. Actually, last big hurricane we have here in New Jersey, Sandy, our radio withstand Sandy, and there was no link loss even with this gust wind of 100 of amount of wind gust. Still, the radio is on, even compared to other radios that basically went down. Our link went on, and this was of the feedback of one happy customer out of New Jersey. The product metrics, the light version of the TDD product is the 1200 TL, which, as we said, throughput is 700 meg aggregated, which means 50-50, 350 each direction. And as we discussed, we can play with the symmetry. We have the 1200T, again TDD product, up to 1,000 meg, again aggregated, and you can play with the symmetry. The default capacity can be lower from 100 all the way to 1,000. It's a license that you purchase, and you can upgrade your radio. Very easy process. Discussed additional features such as sync, E, 1588 OIM that you can add to the product. Again, just a license upgrade. And the 1200F, which is an FDD product, all the way full GIGI, this time full duplex, and all those optional licenses such as encryption, capacity, same way of default product comes with 100 and goes all the way to 1,000. Additional of synchronization, OIM, encryption, etc. So the system components, we have the ODU, which is with the integrated antenna in case of if it's a 1-footer, and the mounting kit. If it's a 2-foot, it comes with, as I said, 2-unit solution. Requires the antenna and the radio and the mounting kit, and then there are power PoE or DC power supplies according to your needs. The PoE, because there are different power requirements between the TDD product and the FDD product, so you would need a different PoE. The FDD requires 45 watts, the TDD 35 watts. So for cost optimization, you have 2 items, but obviously if you buy the higher capacity, it can serve both the TDD and FDD products. So this is the price list. The TL, as you see, very cost effective, 3,500 for a link. This is for a link, and as we remember, we're talking here about 700 meg aggregated, which we can divide asymmetrical throughput 1090 in case you want and you have a certain application with obvious one transmission, one dominant flow of traffic. 7,000 approximately the TDD, the 1200T, and approximately 11,000, sorry, 1200F. There's a free capacity upgrade until the end of Q1, meaning until the end of this month. Not too much time left for that, I guess. And the price includes all the necessary elements, the mounting kits, the capacity, obviously the antennas, as part of this price. So how we use those products, basically, it's ideal for backhaul, it's ideal for fiber deployment, fiber extension when you don't have your availability to deploy fiber in areas that fiber is not reachable, such as building to building, or cameras in some areas, or traffic cameras, or security cameras, etc. So, but it can be also deployed for as in campus or DSLAM aggregation or any backhaul, obviously small cell or base station aggregation. So here's some numbers here, just indicative numbers about, we talked about the capacity and the rain absorbance. So I have a couple of examples here about, target availability and capacity versus the throughput. And remember, we talked about the adaptive modulation. So basically what happened if we see raindrops and we see that the link budget drops, we can kick down the modulation. We basically can receive, we will receive lower capacity, but on the upside, we will see that we can still maintain the link at very reasonable availability, and for very long distance. This is more than 2 miles, and this is actually 3 miles. So installation, and basically what we see here, you see the numbers in minutes of the downtime from modulation. So if you just look on one example, let's target here of 1 gig 4 nines, basically we can have this availability approximately for 4 nines for approximately 2 kilometers, which is kind of 1.5 mile link. And if we're looking approximately to 2.5 miles, we can have 100 meg to this distance with this availability. So this is an example of Vegas. There's an example from New York. Obviously, New York has more moisture, so the numbers are the link distance are shorter for same throughput and the same availability of 1 gig and 4 nines. We can have only 0.8 mile, and if we need more than that, we can apply the 2-feet antenna, and we have mile, let's say 0.1, and we'll have our full GG to 4 nines availability. By the way, for non-availability, it's a downtime throughout the year of 52, 53 minutes. So it's not, it's I would say very limited downtime. And if we apply the automatic bandwidth and control modulation, basically we can have more availability, more than even 5.9 availability for certain application. One of the nice things about ABCM, I didn't say that, is that ABCM basically include built-in QoS. So if you have your ability to prioritize different services into different priority, we can honor this priority, and basically when we start to drop modulation and there's less capacity, we can prioritize mission critical application. So those mission critical applications would still continue running even if the capacity is lower, obviously on the expense of less important application. So the real mission critical application still will have higher availability and will still be available for your customers. So this is very useful feature. And this is another example from Atlanta, Georgia. Again, slightly different numbers, but I guess you got the idea by now. So discuss the application. I mentioned fiber extension, business fiber backup, campuses such as hospitals, universities, and easy you can go from rooftop to rooftop and extend your services very fast. Again, different type of application. We can have a ring. We can have a daisy chain. Daisy chain is used when you have very long link and you want to still do it via the air. If you just cascade the link, you can achieve very high distance using just an intermediate pole in order to daisy chain the link. The delay over a radio, over a link is minimal. For the FDD product, it's approximately 200, 250 microseconds, so it's really minimal. So you can basically daisy chain a couple of radios in line to have your higher, let's say, longer link available for you. You can create a ring. You can create a star using the same radios, and obviously it's, as we said, affordable. If you compare it to fiber that they need to right away, you need to have a truck roll, you need to trench, you need to have a big project coming for you. Your rollout is a snap. And if you compare it to either microwave technology, basically your licenses very high and your throughput, your capacity is limited. So your licenses fee obviously very high. And if you compare it to the $75 you pay for 10 years, it's and then the throughput you're getting is really very competitive and appealing solution. So we have a product which is a carrier class. Actually, it's been deployed by carriers around the world, trials by carriers around the world. So it's really a good product to take. Field proven product. If you are concerned from a rain, Just to give you another example, we have this product trialed in India during the monsoon season. Very, very, very wet, and still this product passed those trials successfully. It's deployed in very cold areas such as in Siberia, in Russia, and it works very well. Scalable product, competitive prices, so something which really brings a lot of value. Again, if you are looking for alternative, even for application when you don't need a full gig, even 100 meg, 200 meg, this solution is competitive and really can be a good replacement for other technologies, for other wireless technologies, and obviously fiber technologies as well, in terms of the performance, in terms of the prices as well. Thank you for listening. I'm open to questions.
All right. Thank you very much, Mahdi. That was fantastic. That was actually very thorough. So we'll see. Let's see. We've got a question. How can we get a copy of the presentation? I can answer that one. The presentation will be on YouTube. The whole webinar will be up on YouTube within the next few days. If you want a specific copy of the webinar, you can email us at sales@microcomtech.com, and we can get you that. Let's see. Other question. This one's for you, Mahdi. Do you have more sales for the EH1200TL for the 1-foot or the 2 kit?
Okay, so I would say that most of our installation are a 1-footer, but there are also, I don't have the exact percentage, but the vast majority is 1-foot.
Okay, so that's the better selling product.
Absolutely.
Okay, well, it looks like those were the only 2 questions. Yeah, you did a fantastic job. It was very thorough. So thank you, everybody, for attending the webinar. Thank you, Mahdi, for presenting it. Again, if you have any additional questions, as I've already said, you can contact us at sales@microcomtech.com. If you wish to view any of the products mentioned here today, you can visit us at www.microcom.us. And as I said previously, the webinar will be posted on Microcom Technologies' YouTube channel for later review. I hope everybody has a wonderful day. Thank you, Mahdi.
Thank you. Thank you all.